Okay, welcome back. One thing I wanted to remind you of, and I wanted to come back to the slide because this is such an important part of recursion. There are two things that you need to know as part of recursion, and one is that one or more base cases are used to stop the recursion. So if you don't have those base cases, then you could potentially have an infinite loop. Um, every recursion, every recursive call is going to reduce the original problem and bring it closer to that base case. And this is an important thing too, because you want to remember that sandwich that we talked about at the very beginning. We're taking a bite of the sandwich. With each bite, we're reducing that sandwich down to the very last bite. Okay. And here's a really interesting problem. And one thing we haven't talked about with recursion yet is what that looks like in code. And that's just as important as understanding the concept of recursion. So let's talk about what that looks like in code. So we have this problem here, and what we want to do is print some kind of message n times. N is some number, okay? So we're going to break this problem into a couple of subproblems. So one is to print the message one time, and the other is to print the message for n minus 1 times, okay? So the second problem is the same as the original problem, but with a smaller size, okay? So again, we're breaking this problem down to a smaller problem each time we go through this recursion, okay? And the base case for this problem is going to be n equals 0. So let's look at this in code. So we're invoking a method called nprintln, and we're passing it a string called welcome, and we're passing it an integer, the number 5. So if we look at the method definition just below that, we can see that we are passing in that string and passing in an integer, and then we have a condition. We have a condition that is going to let us know that when times is greater than or equal to 1, okay, when times is greater than or equal to 1, we're going to do something, okay? So as long as times is greater than or equal to 1, we are going to print whatever that string is, and then we are going to call nprintln with the message, and then look at this. Here we go, right here, times minus 1, and times is that integer that we passed in, right? So this is that second problem that we were talking about. So we've just reduced that problem by n minus 1 times, right? So each time we go through this, we're calling our method nprintln. We're entering that message, that string, and then we're reducing the problem by 1 each time we go through it, okay? Until we get to 0, and then we're going to exit and pop everything off the stack, okay? So this is a good one to use your notebook and actually write down on your notebook the stack and what that looks like, okay, in memory. I encourage you to do that. If I was in the classroom, I would do this on the whiteboard and actually show you on the whiteboard what this would look like, but you can also do that too. So let me see here. Maybe in the next video, I'll actually show you how that works on a piece of paper. So here's another problem. We've already looked at the palindrome problem through a loop, but we can actually do the same problem and solve the same problem recursively. And you can see that we actually have 2 base cases in this problem. So we're passing within palindrome a string, and as long as the string length is less than or equal to 1, we're going to return true. Or we're going to check the length of the string, length of the the strings at char at the string 0 at that, remember our length is 0 to length minus 1, so we're going to continue to check and see with each iteration whether or not the first and the last characters are the same. Okay. So if one is true, so if either of those conditions is not true, then we're going to go through and do an else. We're going to return the palindrome. So this is palindrome. So we're checking is palindrome again, and then we're going to go ahead and reduce the size of the palindrome by 1. Okay, so we're actually going to get a substring of the original string to go back through the method and determine whether or not it is a palindrome or not. Okay, so again, we're reducing that problem until we get to one of the base cases, and then we're going to exit. Okay. One thing that we need to know about is the recursive helper methods. And the recursive helper methods are really important because they can help us reduce that problem a little bit further. So in this case, we are using our helper method here to reduce the problem by decreasing the number of characters in our string. Okay, so we're reducing the number of characters in our string using this first helper method. Okay, and then we're going to pass it into our next method. Okay, so you can see what I want you to see is in the helper method we have is palindrome, and then we're returning our method with s, which is the string, an integer 0, and then the length. And you can see in the next method is palindrome. Now we have 3 parameters that we're passing in. We have a string, our low number, and our high number. So that's the number of characters within our string, right? So we're at 0, and then we're at the length of the string right now at the very beginning. So as long as our high is less than or equal to our low, we're going to return true, and that's our base case. Okay. Else if our char at low does not equal our char at high, then we're going to return false and it's not a palindrome. Else we're going to return palindrome and we're going to make it smaller. So now we're going to go ahead and decrease our string by 1 on each side. So we're reducing our problem into a smaller problem. So many students ask me this question a lot. So recursion versus iteration. So recursion is an alternate form of program control, and it is essentially repetition without a loop. But recursion can require quite a bit of overhead because each time the program calls a method, the system has to assign space for it. That's where our stack comes in. So because the system assigns space for that method, it has to also assign space for all of the method's local variables and parameters, and it can really turn into a lot of memory and a lot of time to manage that additional space. So it's not always the best way to solve a problem. It can be the most efficient way to solve a problem, but not always. Okay. This is a fun little recursion problem that I encourage you to go look at. Usually I run it in class, but since we're not in class, I encourage you to go kind of play with it and see what it is. But it's just a fun little way to learn recursion. So that's the final slide for this video. I'm going to go ahead and do one more video with a couple of problems and also kind of leave you with um, a few things to think about in the future.